have to make sure that you know the electromagnetic spectrum. There's a picture of it in your booklet. I'm only going to go over a couple of things for the spectrum that you should kind of just know as basics. The first thing is question number 1. Compared to the speed of sound wave in the air, the speed of a radio wave in air is going to be greater. So radio wave, because it is an electromagnetic wave, means that it is traveling at the speed of light, which is the same thing that you cannot say for a sound wave, because sound waves travels at 340 meters per second. Make sure you know the speed of sound and you know the speed of light, which we're going to talk about here in a minute. An electromagnetic AM band radio wave could have a wavelength of, and your answer choice should be 500 meters. So 500 meters is going to be your radio waves, which is actually quite large, and then it's going to decrease in size as you move across the spectrum. Question number 4. In a vacuum, all electromagnetic waves have the same speed. Characteristics for number 6. Which characteristics is the same for every color of light in a vacuum? Again, have the same speed. Okay, question number 8. A FM radio station broadcasts a signal at a frequency of 9.15 times 10 to the 7 hertz. Determine the wavelength of the signal. So velocity, again, equals frequency times wavelength. So in this case, though, this is light, or this is technically electromagnetics, so which that means that it's going to be traveling at the speed of light. So this is 3 times 10 to the 8th meters per second is the length, the speed of light. So remember, sound is 340 meters per second. Light is 3 times 10 to the 8th meters per second. This equals your frequency, which is given as 9.15 times 10 to the 7th times the wavelength, which is what we're looking for, and your wavelength should be 3.27 times 10 to the 14th meters. Okay. And then the last question is going to be question 21. And it's just reinforcing what we said before. What is the speed of a radio